This is Austin Manahan recording for ECEN 423, homework 10. This is part 2. As I stated in my previous video, it's doing the vending machine problem. Made the following changes: that the amount remaining items will display, money entered will display, how many items have been purchased. So in my previous video I explained the state diagram as well as the functioning of the finite state machine. So in this I'm going to explain the counter. This is integrated with this test bench, which links all three of them again together. I'll go over that briefly as well. So everything's pretty standard. Clock reset, dimes, nickels, and quarters, and this also takes the item vended, which is fed in from the finite state machine, and select candy and select chips would be obviously user inputs. C and CA are, as I previously explained, for FSM. Those are basically what drives the sequence detector for the finite state machine. Money, items purchased, remaining items, and don't have that anymore. So money, items purchased, remaining items are all displayed in decimal form, ranging from 0 to 100. So obviously everything's pretty straightforward. You gotta look for counters, gotta lay out your signals. This is what determines the price for dimes, nickels, and quarters, as well as counts, and TMP is just the signal used for money. So again, obviously you have your clock reset process. Reset is 1, TMP equals 0. So syncing it to the clock, TMP is equal to TMP plus nickel plus dime plus quarter. So before we get further down, I defined what N, D, and Q are going to be. So nickel, dime, and quarter, what their values are, and again sync those to the clock. So if N is 1, then nickel value signal will be equal to 5. If not, it's equal to 0. And pretty much everything else, same thing for there it is. Okay, case D, that's weird. So same thing for dime, 10 cents, quarter, 25 cents. So then you have the item counting process. So when the counter receives the item vended pulsing high from the FSM, it changes the count signal to count -1. If not, then count remains the same. Going to the vending selection, which just takes TMP, select candy, select chips. So I set the price for chips as 65 cents. So when it is that value, if select chips equals 1, obviously it's going to send the signal to the FSM to change the state, which will vend the chips. If not, it stays in that state. Then when you go to 5, I set the price for. Okay, so let's set the price for candy for 95 cents. So if select candy is 1, C8 is 1. Else if it's chips, then it's going to disperse the chips. Else it's not. And then the others. Obviously, if it's not any of those prices, it's not going to change any of the states. That's linked up money to the TMP signal. Items purchased to 100 minus CNT count, and remaining items is equal to count. So go over simulation. Alright, so as you can see here, the key track of money entered, so nickel, dimes, and quarters entered, it increased as such. Go back to the beginning, actually, now I think that. Alright, so from the finite state machine, obviously you have your nickels, dimes, and quarters. This would have been, so candy would have pulsed high if the user had selected it, so it did, the user did, so I'll reset to state 0. Also reset the money count, and as you can see from here, items purchased increased by 1, remaining items decreased. So I set the remaining items as 100, so obviously as more items are bought, items purchased is going to increase as well as remaining items. So continuing down the line, this is when the chips were bought again, so it's going to keep counting up in that process depending on how much is needed, how much is entered, and what the user buys. This will conclude this video.